Welcome to this first look at Service Bus notification hubs. Push notifications are a very important part of the multitasking experience of all the mobile OSs that we currently have in the market. We have Windows and Windows Phone, which have live tiles and toast notifications. We have Android and iOS, which provide a notification center and also provide badges, effectively numbers you can annotate on the application icons. All of these facilities are there so that services that run in the cloud or run in hosted services can notify the shell that something of importance in terms of data has arrived for the applications. Applications are not always active, and if they were, they would drain the battery too quickly. So most mobile operating systems today are suspending applications while they're not active, so those applications cannot use network services. Push notification services provide a single avenue, a single socket into the mobile phone, into the device that is maintained in a special way so that the antenna can go in low gain and therefore battery can be preserved. As a notification arrives, that notification is mapped to that shared channel through a push notification service. How can an application deliver notifications? The app on the phone or on the tablet is typically paired with an app service. That's a service that's specifically written to be the backend for the application. And inside of that application or external to it is an event source. The push notification service is something that's provided by the operating system vendor and that interacts directly with the operating system shell. For Apple, it's the Apple push notification service. For Microsoft, it's the Microsoft push notification services for Windows Phone, or the Windows notification services for Windows 8. The interaction for most of those APIs happens in the following way. The application first registers with the push notification services through a platform API, and with that obtains a key. That key may be a channel URI or maybe a device ID, and that key identifies the application instance registration with a push notification service for later delivery. That ID is then provided to the application service, which is hosted somewhere on the public internet, and which then stores that ID into a registration database. As an event is raised, the application service will either look up the matching registration, or it will, in a broadcast fashion, go through all the registrations and then deliver to the push notification service an appropriate message that encapsulates the event data. And the push notification service will then deliver that notification to the application or to be precise, to the operating system shell, which then projects it onto the application's icon or onto the application's live tile, depending on what the experience is. If there are errors in delivery, the push notification service will report that to the application service, which is then in charge of, when needed, blacklist or remove stale registrations. Typically, the push notification services employ some kind of proprietary protocol to do that kind of interaction. The Apple push notification services, for instance, are using a proprietary TCP protocol. To help with this, there's a number of commercial push APIs on the market which provide an abstraction from those proprietary protocols. In these interactions, the application, again, uses the native API for the push notification service to obtain a device ID or a channel ID. Will then provide that to its own application service, which then again registers it into the database. When an event gets raised, the application again goes through its registrations. However, here, it's now possible through the intermediary to provide a batch of device IDs that can be provided for batch delivery. So you interact now with the push API, which then goes and calls the push notification service, and for a batch, it probably gets called multiple times. The notifications are being delivered in that step, and if errors occur, they are reported back to the notification intermediary, which will also note success and failures in statistics. And then ultimately, the failures are going to be reported back to the application service, which can take the failed deliveries out of the registration database. So we have a proprietary protocol up on top, and we have now a standardized an HTTP API at the bottom, which makes it easier for the application service to push notifications if it's written in a language or written on a platform that prefers HTTP interactions. Service bus notification hubs provide another layer, an additional layer of abstraction. The application will still register with the push notification services, but it will do so through the Service Bus Notification Hub SDK API. That turns this registration and the registration with the backend system into a single step. You'll also notice that there is no dedicated application service anymore because Service Bus provides such an application service for you. The Notification Hub takes care of doing all these registrations and doing all the maintenance of registrations for you. And you can store hundreds of thousands of these registrations in Service Bus Notification Hubs. As an event is raised, that event is submitted straight into the Service Bus Notification Hub as a message. And you can send messages in its native form, so you can send a native Apple push notification JSON message, or you can send a native Windows 8 or Windows RT XML notification message for live tiles. Or you can send a template, which I'm going to discuss in a moment. And then Service Bus is going to go through the registration database and is going to look up the matching tags. There's a publish and subscribe model here. Or it will broadcast to all the registrations that exist. And it will do so through the native push notification services into the operating system shell. The registrations, as said, can be in the hundreds of thousands. And what we aim to do is to provide a high degree of parallelism of the delivery so that we can minimize the time from delivery of the first to the last message. So one of the design goals here is to make this enormously suitable for new services and for sports services which require low latency in delivering messages. Templates are another innovative feature of Service Bus Notification Hubs. Here, the application is fully in control of its own experience. Instead of accepting notifications that are formatted by some external application, by some external backend, the application provides the exact format of notification it wants to receive. To do so, it sends a template constructed by the native API. So you can create a toast notification or a live tile notification based on the Windows 8 API, as you would do for a local live tile or a local toast. And you fill in the content placeholders with an expression provided with a expression language that Service Bus gives you. That registration, the template registration, goes into the Service Bus notification database. And as events get raised, those events now can become raised as key value pairs. And then Service Bus, as it looks up and iterates over the registration database, will merge the template for each individual device on each individual registration with the inbound message and push that through the push notification service to the application. So we're turning the relationship between the backend and the front end around, and we allow the application experience to be fully in control, not only of the primary experience, but also of the push notification experience. With that, we allow deep localization, we allow deep customization for the needs of the application, and also allow you to have user preferences play a role in push notifications and how the user wants their lifestyles presented, even though you might be targeting hundreds of thousands of application instances with a single input message from your event source. Push notifications to the Apple platform, iPad and iPhone, are delivered through the Apple Push Notification Service. And to use that service, you need to have a profile, you need to have a provisioning profile that is set up for that push notification service. I'm going to walk you through that process of how to achieve this. I'm going to go to the iOS Dev Center. You need to have an iOS development account with Apple. And so I have one, and if you're an iOS developer, you will certainly also have one. I'm going to sign into mine and proceed to the iOS provisioning portal. In the iOS provisioning portal, I have my developer certificate, which I got when I signed up for or renewed my developer account with Apple. Here are my devices, my local devices that I have a provision. That's my iPad that I have here. And now I'm going to create a new app ID for a new project that I'm going to create in Xcode in the following. So I'm going to create a new app ID. I'm going to call this Vaster's Push App. And I'm going to do the same thing here. I'm going to call it Vaster's Push App. And that's my bundle identifier, and it's important to have that bundle identifier be the same in the application you're going to create later. So that's the organization name, and then dot and the application name. So that's the recommended practice that you have here. So got to pay attention to this being right, and this must match your application. So I'm going to go and submit this. It's also notable that once you've created an application ID, you can't remove it anymore. So there's no way to remove anything from this list. So I will find my application that I just created here, Vaster's Push App. And now I will proceed and enable this for the Apple Push Notification Service. If I check this here, I can get the enabled these buttons, configure for a development certificate and for a production certificate. We're going to use the development certificate while we're developing. So I'm going to configure this, and the steps are going to be about the same, or are going to be the same for the production cert and the development cert. We support both in Service Bus notification hubs. And so first I need to go and create a certificate signing request. That's a document that needs to be created on the local machine. To do this, I will go to the applications and the utilities folder and launch the Keychain Access tool. The Keychain Access tool has up here a little assistant, a certificate assistant that allows me to create a request a certificate from a certification authority. I'm going to use my account here, and I will go and save that request to disk. And I'm going to put this straight onto the desktop. So now that request has been created, and with that request, I can now go back to this wizard. I will go and choose that file from the desktop and submit that to Apple. Apple will now generate me this SSL certificate with a private key that I can then download to my local machine and import. So here it is. And now I can go and download that cert. That cert now went to my downloaded folder. And I can go and configure that. And we're going to do that in a moment. So I'm going to click done here. We're not completely done on this portal yet, but let's go and take care of the certificate that I just created. So I'm going to go into Finder, and in Finder under downloads, here's my certificate. So I'm going to go and grab this and just double click it. And now I have Vasters.pushup. Now I have that certificate here. So what we need to do now with that certificate is we need to go and export that, so that we can configure this on a brand new Service Bus notification hub. So the way to do this is to do the export, the context gesture in iOS and go and export it. It's effectively the right click. I'm going to call this Vaster's push app dev. And I saved this as a P12 file, and I'm going to give this a password, which I need to remember because I need that in a moment as I go and import that into Service Bus. So I will go and save this, and also I need to provide my local account here for permission to export that from the keychain. So I'll do that here too. So now I've exported, I've imported this certificate, and now I've exported it again as a P12 file, which I can then reuse. Now, there's a bug in the portal right now, in the preview portal, that doesn't allow you to use the P12 extension, so pay attention to this step. So you simply rename this to PFX. The format is actually the same. And so we need to turn it into a PFX file. That's a bug in the portal that we're going to go and correct. So now, with this certificate, with the setup that I have now the permission to push into the Apple push notification service into the sandbox portion of that push notification service. So we're going to now proceed to the Windows Azure portal and go and set this up, and then come back and complete the application here. So now I'll go to Windows Azure, to the portal. So I start at windowsazure.com and now go to the Windows Azure management portal, manage.windowsazure.com. I'm going to log in with my Windows Azure account, which happens to be equal to the same name. And here I will go and simply click the new button, go on App Services, go to Service Bus Notification Hubs, and call Quick Create, where I can now put in Notification Hub name. I'm going to call this My Hub. And I can pick the region here where I want this to be created. I'm sitting in West Europe, so I'm going to use the Western Europe Data Center for this. And I can go and put in the namespace name here, which I want to create. That's actually fine. I'm going to go and extend this with Europe West. And that's my new notification hub that I'm creating for this application. I'm going to check this up. And now it's creating the namespace in the Western Europe data center. So it's deploying that new namespace up there. It's taking a little moment. It's now, the creation date is now set. And now the namespace is active. I can go in and I will see that under the resources, I now have my notification hub. So I can go and select this now. There's nothing happening yet in that notification hub. So you see the statistics. We're going to see those later. And I will go into configuration. And now here in the configuration, I'm going to associate that certificate that I just got from Apple, and or that I re-exported from my keychain, and we'll put this in here. So I go to documents where I put this, and I have this here. That's the Vaster's push app dev.pfx. I'm going to choose this, and I gave this a password when I exported it, so I'm going to reuse that password here. And I'm going to check, because it's a dev certificate, I'm going to set this as the sandbox cert, because iOS, the APNS service, differentiates between the sandbox mode and the production mode. So that's a dev cert that needs to go through the sandbox mode. That's what it's provisioned for. So I set this. We do a verification on the back end, set this in. Now this all happened. And now the notification hub is already good to go. It's already hooked up to the Apple push notification service. So that leg of that communication path from the Service Bus Notification Hub to the Apple push notification service is now done. So what we can do is we can go back to the provisioning portal here for Apple and complete the steps that are necessary to actually get this working for a new Xcode project. So I'll go to the provisioning step here. I will now create a provisioning profile for development. So I'm creating a new one. I'm going to call this Vaster's Push App. I'm going to take my developer certificate. I'm going to take the Vaster's Push App app ID, and we'll pair this with my device. So now I have a profile that ties all those things together. And we'll go and submit this. Now that's pending. That's being issued, verified, and issued by the Apple server. I'm going to reload this page. Here it is. So that's now active. And I can go and download this to my download directory. Let's go in Finder to my downloads directory where I put this. And here is the mobile provisioning profile. And what I'm going to do is I'm going to now put this into Xcode. That's the first time we touch Xcode in this walkthrough. Xcode being the IDE for Objective-C provided by Apple. I'm going to double click this, and this will launch Xcode, and will actually get me into the organizer of Xcode. Here we go. And now that has been imported into Xcode as a provisioning profile. And that provisioning profile is now something that we'll go and leverage for our application as we deploy this. So the provisioning profile is not yet on my iPad. And so I can go and put that into the iPad here. Now the provisioning profile actually sits here. So once we've done those steps, now that's associated, we can actually go and build the project that's going to be leveraging that profile. So to do this, I'm going to go and create a new project. I'm going to pick the master detail default application because that's inconsequential. What we're going to customize here is going to be the same for all kinds of apps. And I'm going to pick the product name. I'm going to go and call this Push App, and the company identifier, and that together builds the bundle identifier. So that's very important that matches the bundle identifier that you have in your app ID. So you may want to go and create the project first and then create the app ID on the portal. You can also do this the other way around as I've done that. So, but it's important that the bundle identifier matches the app ID that you've created on the portal and that we've imported into the provisioning profile that we imported into our application just a moment ago. So I'm going to say next, and I'm going to create a new folder. I'm going to call this Push App, and I'm going to create this in here. So it's now in creating that application. So now the first thing we're going to do is we need to enable code signing because it's important to go and deploy this. So in the project settings, I'm going to go into the build settings, and there's a code signing area here. And we're simply going to have Xcode help us picking this here. And now it's going to set this all up for code signing automatically. So I set this up using the imported profile. I'm going to save this, and we can go and proceed to the Push App delegate file where we need to go and effectively integrate our SDK. So now to get the SDK, to get the bits and pieces, you need to hook up to Service Bus notification hubs. One way to get at this is to simply go to the portal, to MSDN, and find this wonderful document that we have here. That's the how-to Service Bus notification hubs. That's also linked here at the bottom of this blog entry. And so you can go here, and then we explain how to do those things. And there's actually the iOS SDK framework you can get. So you can click this link, and that will actually get you that iOS SDK framework. We're going to have a more prominent location, obviously, as we're going GA with this service. So now it's in downloads right here. And from the downloads, you can grab this and effectively put this straight into Xcode. So I'm going to grab this file, switch over to Xcode again, and drop this into this frameworks node. Now, the wizard is going to pop up and it's going to ask me, where do you want to go and integrate this? Well, we're going to integrate this into both apps. Oops! So I want to go move this to frameworks, obviously. There we go. So now it's in frameworks, it's stored in here. That's where we want to have it. And as we've copied this over, now it's actually available in Xcode to import. So we're going to go and import this, and we're going to pick Windows Azure.messaging.h. So that's now here. And we're also going to go and add a property straight to this app, a global property effectively, which is going to be strong, non-atomic, and that's going to be a SB notification hub reference. And we're going to initialize that one in a moment in the app.delegate.m file. So this was in the header file. Now we're going to go proceed to the M file. And we're going to initialize this did finish launching with options is the callback that's being called by the operating system shell as the application has been launched or is in the process of launching. And so the first thing we're going to do here is we're going to go and hook this up to Service Bus. So the first thing we need to do is we need to have a connection string. So we're going to have an NS string, and we're going to call this connection string. And we'll have a little helper to help us with that. So we're going to make a connection string. And we're going to make this a string with endpoints, with a listen access secret. So that's the one that the overload we want to do. And we're going to pick the namespace, fully qualified namespace identifier, and we're going to communicate with it with HTTPS, nothing that you need to do yourself. We're going to do that for you. And as I configured that on the portal, it was myhub-euw -1, was it? Let's go and take a look. -ns servicebus.windows.net / that's the trailing slash is right now necessary, won't be necessary in the future. And now I need to have the listen access secret for that particular entity. So we're going to go and grab this here using this button here, the view SAS key that will pop up this dialog. And what we want is the listen shared access signature, not this one, but the listen shared access signature. So we're going to go and click here. It's going to put this onto the clipboard. And from there, we're going to go and put this in here. So now we have the listen access secret in here. And that creates us now the connection string. So having that, we'll proceed to go and use it. So we have the property, and we're going to make the self.hub. We're going to assign that a new notification hub. So we need to go and make that notification hub. Oops, SB notification hub, and allocate that. And we're going to allocate that with the connection string. So I'm going to provide the connection string here, and then we need to have the hub path, and that's the myhub hub that we created. Terminate this, and now we have the connection string set up, and we have that assigned with to the notification hub, effectively constructor operation, and now we have a hub. We do this first before we tell the operating system that we even want remote notifications. So we do that to avoid a race. I'm going to explain that to you in a moment. Let's go and set this up first. So on the UI application, the shared application object, what we'll do is we'll register for remote notifications, and there's a number of options that we have. So we're going to go and pick the alerts, and we're going to go and pick the badges, and we're going to pick the sounds. These are the things that you can now go and register 4. These are the ones that you can send. And as we do this, if this hasn't been granted yet as a right, at this point, the application will pop, and that's the operating system will do this, will pop a permission dialog asking the user whether that's allowed. So that's the first step. So we have effectively an OS-based line that will interact with the user, and then we have 2 lines. Well, really it's 1 line because that one is a helper to go and set up the hub, and then obviously the necessary ceremony up on top in the header file to go and declare the hub variable. What we'll do now is we're going to go and proceed to the point where once the notification registration has happened with the OS, so that's what's caused by this, then we need to go and have that hooked up. So this hookup happens here. I'm going to override a method that's called by the OS as the registration has happened, and the override is did register for remote notifications with device token. So that comes here. And the first thing we'll do is we're going to use the hub's logic, internal logic, and it also stores data for you to see whether existing registrations are there that are managed by the hub, and then it will go and refresh those with that new device token. So we're going to go and call self.hub, and then on that hub we will go and refresh the registrations with the device token that was provided to us. So the device token goes here, and then we have this completion method here that we're going to go and implement. So the completion is effectively being invoked as that operation, the refresh, has happened. So there's an asynchronous callback, and I'm going to check whether the error comes back as nil, because we only want to do this then. If that doesn't happen, if the error is actually not nil, then it's likely that something went wrong with your with the operation. That will typically be because you likely have your credentials or your URI here not correct. So let's go proceed here, and now we actually need to go and close that too. This is the callback bracket. So if the error is nil, if everything went right with the registration, which we'll do also when there are no registrations at all, we now want to check whether a registration exists, the default registration exists, and if that doesn't exist, we're going to want to go and set that up. So I will go and again ask the hub whether the default registration does exist, and then it will go and tell us in the completions callback method. So let's go and check that, and if there was no error, let's go and make this error 2 so that we don't have any ambiguities here. So if and I'm going to move this up a little so you can see that better. So if the error 2 is also nil, and what I'm skipping here obviously is the else paths where we would actually log what went wrong. And if it doesn't exist, then we'll go and register it, and you will guess, we're going to ask the hub again that it shall go and create a default registration with tags, and we're going to supply no tag at all in this first step, and then go and go in here and call the registration if that happened. And again, if, let's make this error 3, if now you actually got an error here, if that happens to be me and my habits, if that happens to be not equal to nil, then you might want to go and log that fact somewhere in your application log. We're not doing that here. We're simply going to assume for the moment, probably naively, that it's all going to work. And I'm going to save this file. And that was the step to hook those things up. So we're talking about a refresh, a check whether the registration exists, and then a creation for that registration. So 3 lines of code to kind of hook this all up. And it's all nicely abstracted by an API, so you only need to worry about really interacting with the hub. And there's no backend work that you need to do all this. Building the project succeeds, so that's wonderful. I'm going to run this on the iPad. So it's deploying, and now we're going to switch over and take a look at the iPad. Here's the application running on the physical device. I'm getting asked whether I would agree to having notifications pushed to me. That's the registration function of iOS is doing that. It's popping it for the first time, so I'm going to agree with that. And under the covers now, the 3 lines of code to register with the notification hub in Service Bus have been executed, and we will now take a look at how we can go and interact with the device from the server side by creating an ASP.NET application. To push to the iPad, we're going to use Visual Studio Express 2012 for web. I'm going to go and create a new project here, and we're going to call this Push to Me. Of course, down the road, as we march towards general availability for this feature, we're going to have support for all the other frameworks and cross-platform frameworks that we have APIs for and SDKs for on Windows Azure. So let me just go and empty this and go to the design view and just quickly put something together here. So I'm going to put a text box here. I'm going to put a button here. It's not the most sophisticated thing of all times, obviously. And I'm going to go and click on the button. I'm going to make this a little bigger so we can actually see what's happening. And here in the Solution Explorer, what I need to do is also need to go and add a reference to the Service Bus preview. So what I did is I downloaded the preview assembly and I put this into a directory here on my machine, and then that's how I pull this in. And now it's available. Now I can, in this project, I will add 2 namespace references. One is Microsoft.ServiceBus, and then the other one is Microsoft.ServiceBus.Notifications. And similar to what we did on the iOS side, the pattern is about the same. The class names are somewhat different. I'm first going to create a connection string. So the connection string, for that, there's a connection string builder that can help us with this. And what we want to have here is a shared access secret, and that with full access. The one with full access actually gives us send permission. And so I will go and use the namespace name here, and that was my hub -EUW-NS. And now we need to have the full access secret that we're going to get from the portal. So let's go and switch to the portal quickly. And on the portal, on my hub, I'm going to get the SAS key. Now I'm going to need this key. So I'm going to grab this. Now it's on the clipboard. Let's go back to Visual Studio. Paste this in here. So that's step number 1. Now we need to have a notification hub or notification hub client. I'm going to create that with a factory that's using that connection string. And what that takes is the connection string and then also the name of the hub, which was not my hub. And then once we have this, let's make a little bit of room here, and so you can see everything. And once we have this, we can simply go and start sending a message. And the notification hub already knows Apple, so it wants to send an Apple native notification. It's asking for the payload. For the payload itself, we have a little JSON builder who will help us with that. We can create one, and we simply put in the alert text. And the alert text we get out of the text box that we just put in. And we're going to take the text out of that text box, and we're going to use that to send. And we're going to render that as a JSON string. And with that, send that out to the notification hub as a native notification for Apple. And that's it. So we can go and compile this. This will compile once I add another reference here. you'll run into this, so I'm running into that for you. And that is the system.runtime serialization assembly, very easy to find here, and that helps us with serializing the payloads. We have this. Now that builds, that's fine. So how we're going to deploy this, we want to see this from the iPad. We're going to do this in a very easy way. And we're simply going to go and create very quickly a website on Windows Azure. So let's put this away. It's going to create a new, on compute, a new website. I'm going to create this quickly. I'm also going to put this into Western Europe. I'm going to call this CV push app. That's likely free, that's available. So I'm going to go and create that website on Windows Azure using my free allocation. It's going to take a moment to create. Now the site is available. And here I'm going to go and grab and download the published profile. I'm going to save that to my download folder. And now in here, in my app, in Push to Me, I will go and say publish, import that published profile here, put this in here. Now it has all the data that I need, and we'll simply say publish, and the publishing happens and starts. And after about a minute that I just clipped out of here, we're actually landing on our wonderful page. So now we're going to go and launch this, see pushapp.azurewebsites.net on the iPad and see how it does. So here we're back on the iPad, and I already loaded that page, cvpushup.azurewebsites.net. So we're simply going to put in some text here, hello, and press the button. And we're sending that, we're getting the push notification back, and with that, we're done, full circle, and got a iOS application built with a .NET backend quickly deployed to Azure and about 7 lines of functional code to get that push notification loop going.